Welcome. I'm Raimonds Simanovskis from eazyBI, and I wanted to share you the latest improvements in eazyBI, which will enable you to analyze large number of Jira issues in eazyBI. So earlier my colleague Janis already told from the functional perspective, so what you can do with eazyBI. So this will be more technical-oriented things where I will describe some new, latest technological improvements, how you can do analysis of large amounts of Jira issues. Our guiding principle in eazyBI is that we want to make simple things easy, but complex things still possible. And so probably making a chart out of couple hundreds or couple thousands of Jira issues, that's pretty simple. But so when you have a large number of millions of Jira issues and then doing efficient analysis of the large amounts, so that becomes a little bit more complex. But with the latest improvements, we want to make even these complex things more easy. So the key difference in eazyBI is that we offer this multidimensional data model for analyzing your data. So there are some measures that you can analyze, like issues created, resolved, resolution days, hours spent versus estimated, workflow transitions, etc. And then you can analyze them by different dimensions, like by time, by project, issue type, priority, etc. So to enable this multidimensional data analysis, we need to transform the source data into the data model that is more appropriate for such kind of data analysis. And for that purpose, we have this data import and transformation step, which takes the data from the source, like from Jira or from some custom other data sources, and transforms into this multidimensional eazyBI model with measures and dimensions that you want to analyze. And we take these issues, changelogs, worklogs, and we import and transform them into eazyBI, as well as some other data sources where we can process some file rows, database rows, or JSON documents. And so this is also good for improving your performance of your reporting, as if you have a large Jira instance and you have some traditional reporting apps which issue a lot of JQL queries or issue a lot of SQL queries, that can degrade the Jira performance if there are a lot of users and all the time querying the same data. In that sense, the eazyBI approach that we just do regular data synchronization from the Jira database to eazyBI, and then all the rest of reporting queries are handled by eazyBI and is not causing the load on the Jira system. And that can reduce impact on your online Jira users. And so how it's done in the data center or server world, that so as you know, so there's this large Jira JVM processes with Jira objects with a lot of Jira apps. And then there's also an eazyBI app, but it does the minimal impact does minimal impact on Jira performance, as all the heavy processing is done in a separate eazyBI child process, where all the reporting queries are performed and all the results are cached. And our recommendation is to use a separate dedicated data center nodes for these child processes. And in similar way in the cloud, so where also this reporting processing is separated in our eazyBI cloud, where we synchronize the data from the Jira cloud using REST API, and then all the reporting is done on the eazyBI side and is not causing the performance problems on the Jira side. So that's is the general architecture of eazyBI, and so now if we move to the latest improvements, how to improve this performance and scaling for analyzing millions of Jira issues. So far, if there were large Jira instances, so we were recommending to define and create several eazyBI accounts, where in each eazyBI account just a subset of Jira projects would be synchronized, And then for each eazyBI account, a separate database schema is created with smaller tables which are used for reporting purposes. And our recommendation was that, well, do import up to 100,000 issues per account. So probably it was not a hard limitation, and well, customers were using also larger data amounts, but then it could get slower. But of course, we were not quite happy with that solution and these limitations, and we wanted to investigate it, so how we can improve that. And so the main limiting factor for doing efficient reporting is some limitations of traditional transactional SQL databases like Postgres, MySQL, or Microsoft or Oracle. So this is some example of a typical reporting query where you want to aggregate some measured data, like here these are some workload transitions, and then you want to aggregate them and group by some dimensions, like by time or status category. And so this is one example that I looked from our cloud instance, and then for where there were some 1 million issues, and which generated about 15 million records in the measures table. And then in our cloud instance, based on the load or how many data are cached or not cached, so the typical response time was 20 to 30 seconds. And so we are using Postgres database in our cloud instance. And so that's quite a laggy response time if you want to do interactive reporting. And so one of the main reasons for that is that how the data are stored in transactional SQL databases, which are optimized for so-called OLTP, or online transactional processing. They store the raw data together, so and which is good for when you are inserting, updating rows, that you just insert, update data or append the new data to the database files. Then each row is stored together. So which is good for individual transactions, but for reporting, you typically need just a couple of columns, and then you want to aggregate some couple of columns grouped by other columns. But for databases, so they need to load all the information in memory and then just select the subset of the data. And therefore, typically these databases start to get slower when you have tens of millions or hundreds of millions of records in these tables. And therefore, for some while ago, a new type of analytical databases appeared which use this column-based storage, and which is optimized for online analytical processing. And in these databases, the columns are stored together. So, for example, we had some date column, and we are storing these together, then some project key, issue key, statuses, and then some transition measures. And now in these analytical databases, when you do analytical query, which just needs to use a couple of columns, and then just these couple column data should be loaded, and which is much smaller data amount. The other benefit is that in these columns, there are a lot of repeating values, and therefore the compression could be done much better, and so the overall stored data amounts are smaller. So we have been investigating several of these analytical databases that we could use to improve the performance, and we finally started to use the ClickHouse database, which is probably the fastest open source analytical database currently, and which is also good that it's open source, and then if you want to use and host it by yourself, you can do it without any additional costs like other open source databases. And using, so last year we implemented in our cloud the solution that when you do the data synchronization to eazyBI, so if we identify that the data amounts are large, we automatically synchronize the data to the ClickHouse database. And now, so we can support much larger volume of issues per one account, and so we say that it could be 1 million or more issues per one account. And so if I compare this, this previous example, that the same data amount now synchronized to the ClickHouse database, So instead of these 10 to 30 seconds, so this query was performing in less than half a second, and consistently less than that. And it was about, in average, 10 times smaller database size because it's a much better compression of that. So for the cloud instances, so there's no configuration needed, and already our large customers on the cloud can experience benefits of that because we automatically detect if the amount is data volumes are large enough. We automatically start this synchronization, and so the performance is improved for these accounts. And as we have eazyBI is the same application, both on the cloud, on the server, so we could easily also add it to our data center app. And in the upcoming eazyBI version 7, which will be released soon, so we are adding this ClickHouse database support that either you can install and host it by yourself on some Linux server, or if you are using AWS and you don't want to host anything by yourself, so ClickHouse also provides this hosted ClickHouse cloud service that could be used with that. And so just to show you that, so that it really is fast, so I created locally on my machine the large Jira instance with generated 1 million issues using the standard data center performance testing data set. And so now I reloaded the data and specify that I want to clear all the cache. And so now I have, we can see that its response times are very fast. So I just do the aggregation of issues created versus resolved by years or by quarters or by month. Or I select just 1 year, do aggregation by days, or let's go back to month, and then I can select just one project, or then see that in this project which issue types we have, and which priorities we have, and then, okay, so it finds that from some 1,000 assignees, just 2 assignees have any data there. And so I found from these 1 million issues, exactly this one, so that I was looking for, and that's everything is very fast. And so that was generating all the time online queries to the ClickHouse database, and so the response times are very good. So, but of course, what still can be slow. So if you do custom calculation formulas that iterate through many issues, that might be slow, and so therefore, they're looking at our documentation or write to us and ask for help how to improve the performance, as well as some specific drill-through issue use cases, or using too many dimensions or rows or on columns or multi-value selections. So so not everything will be magically fast, but what we can provide, so therefore we always recommend, so try to use as much as possible these standard measures that we have created and which we have checked that they are fast. And then we always recommend that go through the training videos, presentations that we have, especially how to write efficient custom calculations if you still need them. And finally, so if you are using data center, then some standard recommendations from our support use cases that, well, please provide enough JVM heap memory both for Jira and eazyBI child processes. So now everything is cheap. So in my laptop I have 64 gigs of memory. So I gave 8 gigs to Jira, 8 gigs to eazyBI child process, and so everything works fine with 1 million issues. So use dedicated eazyBI nodes to segregate reporting load. Use the latest database server versions. For example, in our cloud, so we use Postgres. We see that in the latest, starting from Postgres 14, so there are some performance improvements. So please use the latest ones and don't use the very old database versions. Provide enough memory for database server. So there are many eazyBI advanced settings to increase concurrency. So if you have a lot of CPU cores, please take advantage of that one. And use eazyBI usage statistics to identify slow-performing reports so that you know what to optimize. And always use also the latest eazyBI version. And as I said, so soon there will be the eazyBI version 7 with ClickHouse support. So thank you, and so please come and discuss with me if you are interested in that, as well as I will be in the expo hall in the team in booth 21. Thank you.